Hi, in this video, we're going to be demystifying some questions on the power in an AC circuit. Now, but before that, let's review the formula or formulas that are required. Now, the average power dissipated or produced in an AC circuit is given by, average power is given by 1/2 times the peak current times the peak voltage cosine of the phase angular difference phi, which can be theta depending on whatever you're using. Okay, now this formula can also be written as I root mean squared times V root mean squared cosine of the phase angular difference. Okay, so you can always play around with it this way. Now, for a circuit that contains a resistor, okay, for a circuit that contains just a resistor, now recall that in a circuit that contains a resistor, the current and the voltage are in phase. Okay, so it means that the phase angular difference is equal to what? 0. And in that case, if you substitute 0 into this, any of this, you'd see that, let's put it here, you see that cos 0 is 1, and that makes this, so the power dissipated in a resistor will be just I root mean square V root mean squared. I root mean square V root mean squared. Okay, that will just be it. Now you can also rewrite this as, you remember V is equal to IR, so this can be I root mean square squared times R. Okay, so that would be the formula for the power dissipated in a resistor. Okay, now note this, for a purely resistive for a purely inductive and capacitive circuit, the power dissipated is always 0. Okay, for a purely inductive, so for inductors and capacitor, okay, the power, the average power is equal to 0. Okay, and of course I'm sure you know why that is 0. Now it's 0 because in an inductor, in an AC circuit containing only an inductor or only a capacitor, the phase angular difference between the voltage and the current is 90 degrees as pi over 2. Okay, so it means that if you substitute 90 degrees into this, 90 into this, you see that it becomes 0 because 90 is 0, so it makes the whole of this 0, so the power is 0. Okay, so that's basically it. That's basically the concept behind the idea behind this whole power in an AC circuit. Now let's look at a few questions and we apply them. So let's look at the first one. Now this is from Utme 2003. Now a student actually sent this question to me because he saw different calculations, you know, from one blogger and then one education blogger, and then in a textbook he saw something different. Okay, so let's just demystify this question. It says that when an alternating current given by this passes through a 12 ohm resistor, the power dissipated in the resistor is, now recall, you can see that there's a resistor in this circuit, so we're obviously going to be using the P average, okay, or the power dissipated will be the root mean square values. So we have I root mean square. Now because I do not have V, I will just use the second formula that we wrote there, I square R. Okay, now but take note what they gave you here, what you have here. Remember this value here, this 10 here represents the peak current. So we have IO is equal to 10. So IO is equal to 10 amperes. Okay, so we know the relationship between the peak current and the root mean square current. Remember that the root mean square current is equal to the peak current divided by 2. Okay, divided by 2. So it means that the root mean square current will be equal to peak current, which is 10, divided by square root of 2. Okay, and then I'll rationalize this. So the root mean square current will be equal to multiply up and down by root of 2. So I have 10 root of 2 over root of 2 times root of 2 will give us 2. Okay, and 2 will cancel this. We have our root mean square value will be 5 root 2. 5 root 2 amperes. So this is the root mean square current. So that's what we're going to use for the power. Okay, so therefore the power, okay, dissipated will be equal to 5 root mean square all squared times R. What's R again? R is 12. Okay, and this will be equal to, if you square the whole of this, 5 square is 25. Root 2 square is 2, so that's 25 times 2, and that's 50. So you have 50 times 12. Okay, and if you multiply 50 times 12, you're going to have 600 watts. Okay, and that is option B. Okay, that will be option B. Okay, now let's look at another question. Let's look at another question. They said in this question, in an AC circuit, the voltage and the current vary with time according to the equations. Okay, take note of the equations, this and this, and take note of this extra stuff here. Okay, I'm sure that rings a bell. Respectively, where omega represents the angular frequency. What is the average power dissipated in this AC circuit over one complete circle? Now, we're basically going to be using the same formula here, okay? But now, watch the formula here we're going to use is the power dissipated, average power dissipated, okay, is 1 over 2 IO VO cos phi. Okay, now I'm using this because I have them given, right? I have IO, I have VO. IO is this is for I. So remember, this value here represents the peak current. So IO is equal to 5 amperes. VO is this value here. It's 220 volts. Okay, and then this is where you have to, really pay attention. This phi is, remember, it is the angular difference. Now, if you watch, this current leads the voltage by pi over 3. Okay, and this is in the radians, so it means that the angular difference, which I'm going to convert to, we're going to put in a degrees, pi over 3 is equal to 180 over 3, and that will give us 60 degrees. So our phi is equal to 60 degrees. Okay, so now we have everything we need to solve this problem. So we have that our average power will now be equal to 1 over 2 times IO, which is 5, times VO, which is 220, times cos 60 degrees. Okay, I'm going to have to get my calculator out from here, but we can reduce this first, and then we have here as 110. So I have, if I multiply this, I have 550 times cos 60 is 0.5. Okay, so I don't think I'll be needing my calculator here. So it's 0.5. So 0.5 times this is just half of this. Okay, so we're dividing it by 2. So 2 into this is 2. Remainder 1. That will be 7. Remainder 1. That will be 5. So 275 watts is the answer to this question, and that would be option A. Okay, that would be option A. All right, so that will be it. If you have any more questions under this, any confusing question, I'll be glad to solve them when you drop them in the comment section. Please subscribe to my channel. Thank you.